Okay, so this says solve each system by graphing and check the solution. These equations are written in slope-intercept form, so this will be really easy for us to graph. We just mark the y-intercept of each one and then move whatever the slope says, and where they cross will be the solution. So let's see how we do here. For the first one, we have a slope at 2. I'm sorry, we have a y-intercept at 2, and that is this point right here, okay? So let me mark this just in red as this is the equation that we're doing. That is the y-intercept. Be sure you're on the y-axis. Some people I've been observing them confusing and plotting the point on this x-axis, and that is just a fundamental misunderstanding that you really need to avoid because it's not going to be the same. So from there, you can see that we have a slope of -1/2, means rise -1, drop 1, run 2, and we have a point there. I highly suggest that you do several points, and in fact go in the other direction as well, rise 1, run -2. And when we say run -2, what we mean is the run is the x direction, and running in the negative means decrease, and that's moving to the left. So we can put that negative in the slope on the bottom and say rise of 1, run of -2, rise of 1, run of -2, like that, rise of 1, run of -2, like that, rise of 1, run of -2, like that. And then I will take my drawing. Okay, and there it is. That's the line. So let's do the same thing here for the next equation. We've got a y-intercept of 6. That's right here. And then we have a slope of 1/2. That means rise 1, run 2. Rise 1, run 2. We'll keep doing that. And we'll do it in the other direction too. A slope of 1/2 is the same as a slope of -1 over -2. Those negatives cancel out. So of course we've got a slope of 1/2. But what this means when you think of it this way is that you can drop 1 and run in the negative direction. So drop 1, run -2. That one's like that. Okay, and there you get all those points falling in a line, and I'll graph that with it. Okay, so where do they cross? They cross at the point -4, 4. If you track this from the origin, the first coordinate is x, and you go over to -4 to get right below it. And then you go up to +4 for y to get exactly. So we have a solution. We can label that as -4, 4. And we're going to check it. It says check your solution, and what that means is take both equations, plug in those numbers for x and y, and see if it works out. So I'm going to do that. Okay, so I've written this first equation in, y equals -1/2 x plus 2, and then I've substituted in the values. Make sure you're getting them in the right place. The y coordinate should go where y is, and the x coordinate should go where x is. So what we've got now is 4 equals, notice that negative times negative is positive, so we're going to get a positive, and 1/2 of 4 is 2. So we're going to get a 2 plus a 2, and that means 4 equals 4. That checks out. So it works for that one. Okay, so here's the equation that I put an arrow up in blue, and it's y equals 1/2 x plus 6. So when we substitute those values in, we get 4 equals 1/2 times -4. Half of -4 is -2. I'm going to make this in black. 4 equals -2 plus 6. And of course, 4 equals 4. Check. So we've discovered that the solution is the point where they cross, -4, 4, and we plugged it into both equations to see that if those coordinates work, and they do. That is the solution.